Morning, fellas.
Hola.
How we doing?
Better than average. I got some sleep.
All right. That's what I'm talking about.
Who's drilling concrete over there?
I don't know. I think it must be Justin. Justin. Justin.
If he goes to the bathroom, I'm out of here.
Yeah, I'm with you. Oh, connecting to audio. Justin. Oh, well, we'll get started, you and me, Nick.
Okay. I got the reading and the homework done for 1 and 2 last night.
Sweet. Thanks for getting caught up. What I'm going to do is go over with you the answers to those questions.
Okay.
Drilling a hole for the grounding rod. I gotcha. Kind of a weird place for a ground rod.
Don't you have to have a tester to make sure there's so many ohms for continuity when you do a grounding rod like that? You have to have so many to.
I've never had to. Probably depends on the inspector.
We had to do that a couple of times for. We didn't do the work, but we supplied the generators and everything for radio equipment in the oil field, and they required it that so we rented the tester. It was like $200. To buy it was like $2,000.
Yeah, I believe it. Okay, let me look at the assignment here real quick. What I'll do is I'll just share the screen with you, and we'll go over the questions and the answers together.
Okay.
Just want to make sure everybody's got it done, and they do. So, wait a minute. Sort of. Where do I have to grade these? Was there like an essay question in there?
Not that I'm aware of. It gave me a score. On one, I missed like 2. On the next one, I got 19 out of 21. I went through the book on them, a couple of the questions, and some of them I thought I knew the answer to outright, and it turns out I don't.
Just give me 1 second. I gotta figure out why this is so.
No problem. I got my readings, but I'm trying to get caught up on my board too a little bit. And
okay.
It shouldn't be a problem once I get all the. This workspace is ridiculous.
Workspace?
Yeah, I have none.
Like in your living room?
Yeah. So 2 cardboard, like 2 boxes. That's what I'm working on from my recliner, but at least it's comfortable. I tried yesterday, but my garage gets no Wi-Fi.
Oh, really?
Yeah. I'll have to put an extender out there.
So
Yes, sir. I'm listening.
Yeah, so I moved in this setup. I'm in a garage that my dad and my uncle built in East Peoria, and I just brought a bunch of equipment, built this trainer behind me for a class, and we ran cable from my uncle's house over to here, did a little trenching, just kind of scabbed together some network so we could do this, because I can do it from like my phone with a Wi-Fi hotspot, but it just
Yeah.
chews
Good guys.
the data pretty quick. Hi, Nathan. Justin.
Yeah, right now what we're doing is we're running a grounding rod. Hey, did you get the ladder? Yeah. We're running a grounding rod right now. We're trying to go through the concrete, but all right, he said we're running into some rebar.
Hitting some steel.
Yeah. So he said we're just gonna go into the dirt with the grounding rod.
I got you. Well, Justin, we're going to go over homework and maybe look at the next couple labs. So
Okay.
that's what we're doing today.
Okay. I know you guys said you wanted me to go live a little bit when we're putting in this handle.
Yeah, no, that's fine.
But I'm muted though, so we're not. So I'm not disrupting you though.
Yeah, no, you're cool. Just get caught up on the video later if you want.
Okay.
All right.
All right.
Jump in that pool if you get too hot
With the drill.
with the drill.
Yeah, well, we had to fix the outlet out here because the outlet was messed up last week. We had to fix the outlet because the pool was dirty, real dirty.
Yeah. All righty. What am
Okay. Fun times.
Yeah. Okay, so chapters 1 and 2, right? Share. You see me?
Yeah. Okay. When do we have to take the tests?
We'll
the
take the quiz Monday morning. Can you be here Monday
Okay.
morning?
Yes, I get out as soon as I get out of work. I work Friday night, Saturday night, and Sunday night.
Okay. We'll just do a timed quiz. Yeah.
Shouldn't be a problem.
Yeah. I don't know how to do this online stuff.
Make sure nobody's using the book or.
Well, yeah, I mean, there's really no way I can control that, but
No. But as I remember, most of the tests you gave were super easy. If you even remembered anything about the homework, you had the test in hand. There weren't any questions that weren't on there.
yeah. I don't know. I'll think about it.
Yeah, whatever you want.
Right now, we'll just plan on taking the quiz over chapters 1 and 2 on Monday morning, 9.
Okay.
And I'll put an announcement on there for those that didn't make it to class today. All right, what am I doing? Okay, chapter 1. Dead circuits should be checked momentarily by touching them.
Oh.
What'd you have?
locked out and tagged out and checked by meter. Well,
Yeah.
you're supposed to
Both B
supposed
and
to
C.
check, supposed to verify, check, verify, right?
Yeah. Sorry. Okay. I got a sick kid. I'm just checking on him.
No,
Number
that's
2,
fine.
GFCI circuit breaker or receptacle monitors current flow and
Imbalance.
live. Go ahead.
Yeah, the difference in current flow between the live and neutral conductor.
Perfect. Up to how many milliamps did it say in the book?
I thought it was 3. I could from last year. That's my memory. I couldn't find it in the book, but that doesn't mean it's not there. My ability to see it, sometimes I skip over stuff when I'm reading.
I always remember 5 milliamps. The book that we use for 111 says 4 to 6 milliamps, but about 5 milliamps
Okay.
is what I remember. GFCI protects against the most common form of electric shock, the
Ground fault.
yeah.
That's why it's a ground fault circuit interrupter.
Yeah. You could have had a little hint there if you just remember what it stood for.
Yeah.
Confined space is one that has blank entrance
You all right?
by way of location, size, or means.
Confined space is anything that you have restricted access to. You
Restricted.
can't get in. Yeah.
According to Ohm's law, assuming a body path resistance of 100 ohms, what amount of current would flow if a person came in contact with 120 volts?
E equals I times R. So that would mean that E divided by R would give you I.
I
So
equals E
1.2.
over R. Yep. So 120 divided by 100.
Yeah, I said the same thing you did, just remember differently.
Just kind of crappy. Just kidding, Nick. After vigorous testing to UL standards, the product, if passes, is then referred to as being blank by underwriters' laboratories.
Listed.
Listed and labeled. An exposed live wire makes contact with the metal frame of an ungrounded piece of electrical equipment. As a result,
It's ungrounded. You will not blow a breaker. It will not trip or blow a fuse or blow a breaker. The equipment will operate, but you can get shocked. So you could get shocked. It'll be live, right? Okay.
It's a good way to put it. What should you do with a capacitor before handling it?
Lick it.
Lick it.
Discharge it.
Discharge. You ever been walloped by a capacitor?
Yes, I have. I thought I discharged it. I set it on the counter at the electrical storehouse, and I picked it up by the top, and it shocked me.
Yeah, they'll give you a wallop.
But that's only if they it's only if they're powered off in the up cycle, right? They don't always hold the charge. So if you're in the bottom end of
it just depends
sine wave.
Depends on where it was at in the cycle.
Yeah.
Electrical blank is the process of placing a danger tag. I shouldn't even have to read the rest of it.
It's tag out.
Tag out. Generally, any body current flow above how many milliamps is considered dangerous?
5?
5 milliamps. Stands to reason why the tolerance on a GFI is about 5 milliamps, huh?
Yeah.
Keep material or equipment at least how many feet away from high voltage?
10, it says.
10 feet. I think that's a
But
rule of thumb, but like Ameren has their own clearance depending on if it's vertical, horizontal, and all that stuff. But I personally, if I'm in a bucket truck, do not like to be anywhere near the stuff.
when we were in the oil field, we had to move generators that were taller than the lines. So they either had to remove them, and we had to take that laser to see how tall they were.
Mm-hmm.
And out there, they wanted it 15 feet, at least 15 feet from the top of the generator.
Yeah.
And so they'd have to take the poles out all the time for us to get in there.
Yeah, I bet. I mean, a lot of it depends on, I'm sure, how many kVA the power lines are, and like when you're something like that, when you're moving a generator, I mean, it's probably, I guess, depends on how you're moving it, but it's a lot of metallic equipment that's in contact with the earth. So
these were at least 150 kilovolt amps, so they were big generators. We'd pull them out there, and bless those guys, the linemen, because they would just clamp on that live, and I don't know how they do it, man. I don't have the fortitude to hook up the 480 or 7, whatever, Highline 720, I think. I can't remember. It's craziness.
the power, primary voltage.
Yeah, going for the three phase on the high voltage.
Oh man, it's in the
line.
thousands. Yeah.
Is it?
The smaller, like, residential ones are 13,800. But
Okay.
that's line to line. So line to ground, I think, is 4160. So it's 4,000.
Oh. Okay. Yeah, we had a couple of them. At Caterpillar at KK, the drives ran on 14,000 volts.
Yeah, it's crazy.
I didn't work on them.
Yeah. It wouldn't be so bad if you had all the proper training and all the proper PPE. That, you know, I would trust things a lot better that way. But
Yeah, I like going in there haphazardly is never a good idea.
mm-hmm. All right, what does moisture do to resistance?
Decreases it.
Decreases it. What does OSHA do?
They set safety standards for the workplace and conducts inspection tours to ensure compliance. Yes,
sir. What does the National Electrical Code do?
NEC sets the standards for the safest. They give you safeguards. The code, the minimum safety standards for doing electrical work.
Yep. The key word in that is minimum.
Yep.
Amount of current flowing through a body is equal to I equals
E over R.
E over R. Electric shock intensity does all of them. Increases with an increase in current flow determined in part by the pathway current takes through the body, increases with the length of time of exposure. So that's what I always tell people is the three things that determine the severity of electric shock are amount of current, current path, and current time. And then we always get into the argument about voltage, but I don't even want to go there unless you want to argue about voltage versus current.
I don't want to get shocked, so we'll just stay away from it.
Here's my argument. I guess people want to say, well, voltage overcomes resistance, right? So if I'm a certain amount of megohms from top to bottom, then a higher voltage will put more current through me at the same spot, right? So it has to be determined. But current is the killer because current stops your heart. So you could put 1,000,000 volts across my hand and maybe it blows my hand apart, but I still live.
Yeah.
You know, but
well,
if you put
there's a
1 volt across my heart and
it'll kill you.
Stops my heart.
So there's a reason why stun guns are 200,000 volts. It's because there's no amperage involved. All it does is it contracts your muscles. I mean, it doesn't kill you, but it certainly does hurt.
Mm-hmm.
That being said, the higher you get, I have seen 600 volts DC. You don't have to physically touch it, and if the moisture content in the air is right, it will jump and shock you. You won't get a full shock. If you ground yourself, you won't get like a full shock, but it will tickle quite a bit. I have seen that working on drives before.
Mm-hmm.
So voltage is not a good. High voltage doesn't mean you're going to die.
Right. The other thing is where current becomes dangerous is the threshold was 5 milliamps, right?
Yeah.
So take whatever voltage it is. Let's say it's 100 volts to put 3 milliamps across. Let's say it's across my heart, and it doesn't kill me. Let's say I do the same thing with my skin wet. I just got out of a swimming pool, and it puts me at 20 milliamps. Same voltage, right? Different current,
right?
And it's killer. So anyway,
yeah,
I said I didn't want to get into the argument over it, and we did it anyway. But we're both on the same side of the argument,
yeah.
so that was handy. All right. The purpose of bonding non-current carrying metal parts of an electrical system is to
limit the touch voltage fast, facilitate the operation of, or I think all of them, but I'm a little unsure of what touch voltage is.
I'm unsure what that means too. I know the answer is all of them. Establish. I guess what that means is if I'm leaning against a piece of gear and that gear gets energized, there's going to be a really brief amount of time before overcurrent protection cuts the circuit.
Okay.
That's what I take it to mean. I have to look in the book, see what they were asking there. Maybe they don't explain that well, but for the purposes of this class and the quiz, the answer is all of them. When a current is still applied to an unconscious victim of electrocution, your first priority is to
turn it off.
Turn the thing off.
It's every time I hear something like that, I think of Napoleon Dynamite, where they're trying to use a time machine. They're sitting there shocking themselves.
In Napoleon Dynamite?
Yeah, man, you haven't seen that clip?
It's been a long time, but I don't remember that part.
The clip where they look up the clip on YouTube for the time machine. It's hilarious.
Time machine? All right.
Yeah.
When installing new machinery, ensure that all metal framework is efficiently and permanently
grounded, right?
Grounded.
Yeah.
When operating a disconnect switch,
you want to make sure it's not under load, face away from the operating switch. Usually you want to use left hand, right side if you can, or whatever side you want to be away from it, and then stand clear of the box. Yeah. All the above.
All of them. So I always tell people that what I do, especially in higher voltage gear and panels or whatever, and if the panel's open, I stand on my right foot and turn it on and off with my right arm looking away. And like, I also hold my breath. So, and it looks dumb, but because if you get an arc flash, your first instinct, like if you get startled, is to go, So I always like inhale, energize it or de-energize it, and then move on. And then right arm, right foot for me would keep
no path across the heart.
Current path on the right side of my body instead of through my heart. But who knows? That's just my thing. I always tell people that's what I do. And if they want to use it, they can. But like when we're in the lab and we're working on 208 or whatever, throwing disconnects, I always just like, at least, have your safety glasses on, look away, and stand kind of back and turn it on, whatever.
Yeah, I got you.
Just a good habit to get into. Which of the following is a recognized testing laboratory?
UL.
Current imbalance as low as how many? Oh, there we go.
5.
5.
You say, yeah, that's
Blank is the intentional connection of current carrying conductor to the earth.
grounding.
That's grounding. Blank is the joining of all non-current carrying conductive enclosures together.
Bonding.
Bonding. Sometimes people get hung up on those. All right, so that was chapter 1. Whoops, let's go through chapter 2.
I really hope that they don't continue with this into the fall, because I was kind of hoping to take regular classes.
I do too. But I think at the very least, what they'll probably do is do like lectures and stuff online and like come in and do labs or something like that.
Okay.
Because we
That
just
would actually-
we can't sustain this, you know.
No.
It's too important to be with students in the lab for our entire building, you know. Motor starters and electric controller are used to
Start, protect, and stop, all the above.
all of them. All additional start and start or on control devices are wired in.
I had problems with this one. I thought it was series because you don't. I was thinking of the safeties. You know how safeties are. You've got, you know, like whatever machine, the carriage has to be all the way back. You don't want to start it with anything out of position, so they have safety controllers. I was thinking in series of each other, so that way you can't start the machine in an unsafe manner. But that wasn't the right answer.
Well, that would be, safeties would be stops, you know.
Okay, so that would be my mistake. Parallel then.
Anything start, yeah, would be in parallel. All additional, oh, we just did that. In a dual voltage split phase motor, the two run windings are connected in
It's not series.
for high voltage, it's series.
I put that and it said it was wrong.
What?
Because the low voltage is 2 Y windings side to side.
Yeah.
And then what you do when you wire it is you basically snip them, cut the connections, and put them up higher. So it's one single Y. We'll find out. I literally got that one wrong. If you can check it though, right?
Yeah, I'll check it.
Okay.
I'll do it right now if you want.
All right.
No, well, just remind me when we get done. I'll check it real quick.
That's fine.
Let's just get through this. Information required to identify a motor is contained on the
Nameplate.
nameplate. Inverter duty describes a class of motors that are capable of operation
Variable frequency drive.
from a drive. Ladder diagrams show
Electrical connections.
just the connections. On a ladder diagram, all the wires connected to a common point are assigned
The same number.
the same numbers. Conductors that cross each other and make contact are represented by a heavy
Dot.
dot. Single phase motors are
All the above.
not as efficient, constructed mainly in small horsepower sizes, and not self-starting. What is the electrical device and ladder diagram that uses power supplied from L1 to L2?
A load. That's
Gonna be a
poorly.
load. You can make
It's
a case
poorly
for a
worded.
motor, but the motor is a load.
Yeah.
And in a three-phase, yeah, I don't want to go into that. I think it's kind of a, if you got that one wrong, I would give you credit for motor, but that needs to be reworded. But
Yeah.
anything using power, so producing wattage is, or
A
horsepower
load.
is going to be a load. Push button abbreviation,
PB.
but,
And or
circuits, motor control circuits can be broken down into
power and control.
power control. Code letter that specifies the locked rotor current rating.
kVA per kilovolt amp per horsepower.
kVA per horsepower. Motor
I
term
don't know.
auxiliary. Go ahead.
You know that kVA per volt doesn't work, and because it's got volt in kVA, so how would that?
Mm-hmm.
It's already part of the original.
Yep. Auxiliary contact refers to
A contact that is operated in addition to the main circuit contact.
yeah.
Okay.
So what does it mean that if the nameplate of a motor indicates that it's thermally protected,
That means it's internal to the windings.
so it's built in?
I had a question about that if you have a second.
Mm-hmm.
If you hook a thermally protected motor up to like one of the motor starter units that have a thermal protection on it too, will those two cause problems with each other, or will just the lesser one break thermal protection sooner and then it won't bother either one? Like they won't interact, will they?
No, it'd be kind of like,
Okay.
like you said, like safety devices in series.
Okay.
So they'd both, I think they would both operate a little differently, but because I don't know, like the overloads on a motor starter, if they were the same size, might trip at a different time than if they were directly on the motor itself, you know?
Depending on what, yeah. And that, because some of them on the starters are, you can rate them differently, right? For like whether they're slow to break or fast to break, right?
Yeah, that's what the little number code or letter codes on there mean.
Yeah.
But I don't think you'd cause any problems having two sets.
Okay.
Okay, what does plugging a motor mean?
Reversing operation.
Yeah,
We actually have that. Have you seen that before?
Mm-mm.
Yeah. We have mills for the rubber, which are the two giant rollers that squeeze rubber together. And if you get your hand caught in there, it'll just crush it off. So they have a plugger. So if you hit the e-stop on it, or if you hit the bar that goes across there, it'll reverse it real fast. So it doesn't continue to suck your arm in.
Okay, the rotating part of them is pretty simple. Rotating rotor, stationary stator.
Yep.
The three distinct windings of a three-phase motor are referred to as?
I thought it was T1, T2, T3.
Yeah, and that's why I made this one extra credit. in the past
Okay.
because T1, T2, and T3 is correct. But they have phase 1, phase 2, and phase 3. So if you see it on the quiz, remember it's phase 1, phase 2, and phase 3.
On the motor. Okay.
The windings themselves, yeah.
Because the phase is dictated by the line side. On 3-phase, right?
Yeah.
Because if you could hook them up 1, 2, and 3, but if the phasing's wrong, then you have to reverse them.
Right.
Okay, I'll remember that.
Okay. Three-wire control uses momentary 2-wire control, which then down in question 21 is maintain.
Yeah.
To differentiate between normally open and normally closed contacts on a ladder diagram, normally closed contacts are identified as a number which
You're alone on this one. I don't know.
is underlined. So
Okay.
I'll show you on a ladder diagram here in a minute.
It's never been the issue. They've all been NC and O, or the picture will actually show them normally open or normally closed. I've never seen them underlined.
I'll find an example. All right, so all this mumbo jumbo right here, that means that there are contacts elsewhere in the ladder diagram that these coils are associated with. So if I want to know where else is, well, let's see. If I look at, let's see how number rung 12 is underlined. So if I go to rung 12, I bet you I'll find CR1, CR1A, or CR1B, normally closed contact there somewhere. So let's go to 12. CR1, normally closed. See that?
Yes.
Does that make sense? So right here,
okay.
rung 8.
In the key.
Rung 8 is underlined, so there would be normally closed on rung 8. CR2 normally closed.
Okay.
So these
So
numbers.
you're talking about.
Go ahead.
The footnotes or side notes, they're underlined.
Right.
Okay.
Yeah.
Okay.
So these numbers over here would be all the contacts elsewhere in the ladder diagram that these coils are controlling.
Okay. All right, I understand now.
Okay, dual voltage motors operate on a higher voltage rating. The operating
The current is lower.
current is lower. Higher voltage, lower current. Okay, so that is your review for the quiz that we're going to plan on taking Monday morning. And what I've done in the past is just pulled questions straight out of the homework.
Okay. So I'll be sure to be on time on Monday so I can get that quiz, right?
Yeah.
I'm assuming that's how it's going to work. You're just going to wait for us to go online and then we'll do it while we're online, or? how do you want to do
Yeah,
it?
that's the plan. I need everybody to show up if we're going to do it that way. But I'll put
Yeah.
an announcement on there and like send an email out and see if everybody can show up. It's the hard part with an online class is like I can't really make everybody show up at a certain time. I just want everybody to so that we can have the interaction that like you and I are having now, you know.
Right.
But
And showing up for me is easy because I don't have anything during this time, but actually being mentally able to do the work after working 12 hours is
yeah,
the
I
hard
bet.
part.
Yeah, I bet. That's why we can't keep this online stuff up.
Well, I hope not. I would rather be in the shop, in the lab working on the high voltage NEMA stuff anyway. I mean,
Yeah.
this is all nice for DC stuff, which you don't see that often, but
Yep.
all right.
All right. So where do we leave off on the labs?
You showed the push button part of it, and I have all day today to get caught up with the wiring portion of it. I have to do all my jumpers and everything like that. And I had a question for you on these buttons here.
Uh-huh.
You can see them. How do you determine does it have a polarity?
I don't think they're polarity sensitive, but when I hooked them all up, X2 was negative and X1 was positive. They all worked.
Okay,
So
I can live
if
with
you
that.
make the 2s black and the 1s red, it should work just fine.
Okay.
And if they don't, then you just have to switch them. Oh, and the other thing was with those, originally, the first trainer I wired up, I ran a negative out for each one of those. The second one I did, I just put a little jumper in there, and I'm fine with that if you want to do that.
Okay.
So if you had one negative lead coming out of the top of the junction box going to the terminal strip, and then jumpering between the buttons, you save some water.
And the toggle, right? Or are we doing something different with the toggle?
Which toggle? The selector switch?
Yes, the selector
That one doesn't
switch.
need a negative because it's just a switch.
Just passing power. Oh yeah, it doesn't have a light on it. Duh. According to Zoom, your network bandwidth is low and there is no picture. But maybe you don't have a picture for a reason.
Hang on a second.
No problem. Sunny days sweeping up clouds our way. On my way. Yeah. To where the air is clear. There's nothing going on, so I'm singing for everybody. Can you tell me how to get
to Sesame Street?
This is being recorded in front of a live studio audience.
Oh, yeah, and it's going on YouTube. You're going to be famous.
I am famous
I'm
already.
making you a YouTube star.
All right. I'm the next American Idol.
You see me now?
There we go. Now I got you.
Okay. So where we left off the other day was
Single push button to the green light.
yeah. This.
I don't think you had it as a CLN circuit though. Yeah.
Yeah. So that's where we left off the other day. So I'm gonna look at, and I'm gonna do this according to my diagram behind me, but so this would be lab 4, and I will put the labs 4 and 5 on the shared drive.
Okay.
So you can, if you don't work on them right now, right here, then you can work on them on your own time. But I do want to go through wire numbers. So let me zoom out. And that's the crappy thing about this. There we go. Okay, so what would my wire numbers be on here? Let's just say rung 2.
So rung 2, that would be, so you'd have 1 going into the stop push button, and then U2 would be your negative on the other side, L2, right? Or no?
Yep.
Okay. So that means between push button stop and start push button, that would be wire 3.
Yep.
And then between push button start and light 1 would be 4. And then between control relay and line 4 would be, no, that's connected. So that's line 4 too, right?
Yep. They're all on the same potential.
Yes.
So that means is when this gets lit up, this gets energized too.
And that's what drives me nuts, because every time I go to look for something, I think it was a different wire number, and it shows it's connected in parallel, but you never know how they connected in parallel. You don't know if they connected it directly off the push button, the start push button, or if they went 10 feet down, spliced into the line in a junction box, and then brought it down to that control relay, and it would drive me absolutely nuts.
Mm-hmm. Okay, so we haven't gotten into symbols yet, so you may or may not know this, but what does this represent, CR1, this circle?
Control relay 1.
But which part of that control relay 1?
That would be the coil.
That's the coil. And I'm doing this more or less for the people that are going to get caught up later on. But so that being the coil means that we need to know on our little relays where we're taking that wire to. So I'm going to grab one of those relays and we will go through that together.
The ice cube relay?
Yeah.
(13 and 14).
Yep.
Which, oh, we're at on the block, huh?
Right. Okay, so this is one of our control relays that I just pulled off of my trainer. And
All right.
if you haven't seen one of these before, this is called an ice cube relay because, why, Nick?
It looks like an ice
It
cube.
looks like an ice cube. The cool thing about these is that you can see the operation of it kind of the same way on your little 12-volt relay. You can look inside and see these contacts making. I think I did a demonstration of this the other day. Where we energized the coil, which is over here, and it made the contacts move from one state to the other. The same thing happens with these, and these are made in all different shapes and sizes and versions, and I'll get out some more types and we'll look at some like octal bases, but the main premise for the lab is that you just have to understand what all these pins are, right? So if you look on the side of this thing, it just pops out, just stab in connections. And I'm going to zoom in on this. Hopefully you can see that okay. What this is saying in Chinese and in English is that the coil on this one is going to be 13 and 14. So if you look on here, 13 and 14 are indicated with this little arrow right here. So this is 13, this screw right here, because there's a little arrow on there, and this is 14. So when I put, this is 24 volts, right? Yeah, so
yes,
this coil, every ice cube relay is going to have some different ratings on there. This one is operated, what these numbers are saying is that the coil will operate for anywhere with AC 6 volts to 380 volts or DC 6 to 220. So we're well within that range when we're using DC 24 volts, okay? And then on the diagram, it's also showing this little LED right up here. All that's saying is that when the coil is energized, you'll get an indication on this little light, this little LED light on the front is saying, hey, this thing has changed the state of all of its contacts. So when that contact is made, when the coil is energized, it creates an electromagnetic field, which changes the state of these contacts. So without even looking at the diagram, you can kind of see what's going on here. These two top ones alone are going to be the coil, I'm pretty sure. Yeah, because it's going through a little resistor and then makes contact with the coil there and then makes contact with the coil on the other side. Let's see, what else do we have here? That means these pins are going to be, if you follow the ends of those pins, they are all wired together up to this common point, which is going to be the middle tab, the middle contact. If you look in that little window, the top pins are going to be normally closed because they're closed with the common contact right now. And then this row, if you follow that in there, those are normally open.
Yeah.
But the diagram itself is going to show you where on the base to land everything. So let me get it so you can see it. Can you see that okay, Nick?
Yes, I can. I can read it. Is that a lightning mark by the diode? Is that what shows its light? Oh yeah,
that's LED.
Yeah, I got it.
This little diode with the, yeah, that's the LED. So we got, yeah. So pins 5, 6, 7, and 8 are going to be the commons. Or excuse me, That'd be 9, 10, 11, and 12 are the commons. 5, 6,
5,
7, and 8 are normally open. And 1, 2, 3, 4 are normally closed. Right now with this diagram, all we're doing for lab 4A is we're energizing the coil. So all we need to do is take wire to 13 and 14. Make sense?
Okay. Yes. All the switches, all the little buttons that we have that go on the breadboards they're all, did they stay in one state? They're not momentary, are they?
Which
None
one?
of them are the push buttons that came in the little kit that go on the
micro
breadboard.
switches?
Yeah.
Those are all momentary.
Are they?
Mm-hmm.
Okay.
And you'll see if you run these across the channel in the middle this way, like this.
Yeah.
These two pins are normally open. It's kind of weird. You would think that this top pin and this top pin operate together, but it's not the case. I can show you here. So you can see which pins I have, right? These two.
Yeah.
So those are the ones you want to use. And you could use the other side too, but if I'm going in and out of this switch for a momentary on, those are the pins that I would use.
Okay.
Make sense?
Yes.
Okay, so I'll run through this on my trainer real quick, and your setup should be exactly the same. Just with smaller components.
Yeah, I could do that better than I can these little ones.
Yeah, I know, I'm with you, but I couldn't afford or build this setup for all of you in time to start this class, so.
I understand. I was making a statement. I didn't mean to hurt your feelings or anything.
You did hurt my feelings. All right, so what am I doing here? I need and I'm going to emphasize this too, but this entire class I'm going to emphasize hook up a wire and number it before you move on. So in this little scenario, I need wire number 1 to the stop. So it's going to be this guy. Right now, my wire number 1 is going to my start. So all I'm going to do is move this to stop. Right here. So I've got wire number 1 in my to go into one side of my stop. So I'm going to do a check mark. The other side, wire number 3, needs to be a little jumper going from my stop to my start. And I've already got a little jumper wire number 3 in there. I just got to move it to the right places. one going to the start, the other one going to the other side of my stop. So that one is in. Now I need a number 4 going from start to pilot light 1. So pilot light 1, I'm going to make that green. So that's going to be this blue guy. One thing that I've seen some of you guys doing is taking one wire number and putting it right in the middle of the wire, which is fine for little jumpers. They're just going to go across here. But if I take a wire, which here in a minute I'm going to have to do to take it to the coil, that's really long, it's a good idea to label both ends for obvious reasons. But I'll show you that here in a minute. So this is going to be wire number 4. Go to my green pilot line. And I guess for now I'll use my ice cube relay that's mounted, and I'm going I'm not sure this one will. I'm gonna have to look up the specs on this because I don't know if that's a 120 volt coil. What I'm gonna do is run it to this NEMA contactor or control relay, and then on Monday I'll take this thing apart and show you how one of these big NEMA guys operates. But for now, I'm just gonna go ahead and hook it up. So I need a wire number 4 that I can take one of those two points that I just landed one on, and I'll zoom in here. So this wire number here, right here, Nick, is a 4. So does it matter which side of this I pull my other 4 from?
Not that I'm aware of.
No, because they're all in the same potential, right? So what I have landed on the wiring diagram is the start going over to the pilot light. Now I just need to make something wire number 4 that goes over to the control relay coil, right?
Yeah.
I can take it from either one of those 2 points, whichever one I choose.
Yep.
And the coil for this NEMA control relay, sound gravity one, is these top 2 guys right here.
All right. Is it that NEMA one? The contacts are under that front cover, so you can change them out, right?
Yeah. Have you seen these before?
I have worked on something similar. You don't see them as often. Like I said, everything they're installing now has the Allen Bradley style ones don't use the NEMA. They use the all the motor controls are like that we use. They're smaller and
Like these?
yeah, they're smaller than the NEMA controllers, than the NEMA style.
These?
Yes, exactly.
Yep. And these are the same things. I just like these better because you can fix them. You know, this one in particular has normally open, normally open, normally open, normally open. Like you don't have a choice. These ones you can go through and change them, or if the contacts go bad, you can open it up and replace them. I don't know that you can do that with these. You just have to buy a whole new deal. Maybe you can.
You can install a new contact set on the top of the coil. Typically, what you can do, but people usually just buy the whole thing because I have had to mix and match them, and they're modular, so I've had to put them together because we've had certain parts in stores, but not the right ones to fix it. So I'd had to take pieces off of one and put it on another to get it to work.
I gotcha.
The safety interlocks pretty well undefeatable though on the newer ones, so that's what I like about them.
Yeah. All right. So for mine, Let's zoom out here. What you'll see with these big NEMA Allen Bradley contactors is this little red guy is the indicator. So when this coil gets energized, you'll see this red thing pull in, and that means that the coil has energized and all the contacts have changed state. So if this works let me double check my diagram, but I've got that made up. The twos are done. So I should be able to put 120 on this thing, push the stop button, see the green light come on, and the control relay coil pull in.
Is that red part, is that the manual force point too?
Yes. But I always tell the students, do not do that in the lab.
Okay.
You know, but you can actually energize that coil by pushing that thing in.
I do that occasionally to test continuity or to ohm it out to see. But a lot of times if I can get in there to do a voltage drop, I don't worry about it.
Right. Okie dokie, so let's see if mine works. So when I do this, if I push this button in, I should see that light turn on and I should see that coil pull in. Oops, let's see light. Can you see that red thing pulling in?
Yeah, it's laggy, but yeah, I see it.
Let me zoom in because I really want you guys to be able to see that. I hate that it lags. I've gone through and looked at some of the YouTube stuff, and it, like, you almost get a still frame every split second, right?
Yeah.
All right, so I'm gonna push the button again, just so you can see the difference.
Yeah.
So that does it for lab 4. And you notice, and you probably know the answer to this, Nick, but there's no seal in there. So
Yeah.
the next lab we do, we'll add what's called a seal in contact so that when you release the start button, it does not de-energize that coil. So we'll do that on Monday.
Okay.
But I'm going to call that a day for the purposes of you and I having class today.
It's good spending time with you.
You too, Nick.
I'll get caught up can I send you videos via email of what I've done from my phone just to show you different wire numbers? It's much easier than carrying a laptop around.
Yes. So there's a couple things you can do. Let me get out of here so I can turn my camera back on. There's a couple of things you can do. You can either take that video file of that lab working from your phone and email it to me, or you can take the video and upload it to the shared drive.
Sure.
So let me show you how to do that real quick. I would almost prefer it that way so I don't have to keep track of a bunch of emails.
Yeah, no, I understand.
You guys are all comfortable with doing that, and you guys should have the rights to add or delete stuff on here, so please don't delete anything. But
I'll try not to.
This one, Zach's class shared, summer 2020, 150. I'm gonna add a folder, lab submissions. And if you open this up and you have that file, whether you do it from your phone or your computer with a webcam, you can go new, file upload, and then this is actually Tuesday's class. But you should have the ability to upload videos to that, and then just in the title of the video, just say, you know, lab 1, lab 2, lab 3, whatever.
Okay.
Okay,
I got you. All right. I'm going to take today and get caught up. I appreciate the time.
All right, man.
All right. You have a good day. Take care
You
of that
too.
kid.
You too, Nick.
All right. Bye.
Bye.